welcome to the first live Ask Me Anything session for 2021. My name is Adele. I'm a software engineer at GOTO Amsterdam. We have an awesome session lined up for you today with DevOps pioneer Dave Farley. Hi, Dave.
Hi, Adele. Hi, everybody.
Dave is an award-winning author, an independent software developer and consultant. He has a new book out on LeanPub called Continuous Delivery Pipelines, and he'll be speaking at GOTO Amsterdam Conference, which is planned for 15th to 18th of June. So the plan for today is we'll start with the pre-submitted questions. We've received quite a few, so I'm really happy about that. And we'll pick up some live questions as we go. So Dave, look, let's just get straight into it. I'm going to start with the classic interview question of tell us more about yourself.
Okay, it might take some time. So yeah, I'm a software developer. I've been developing rather frighteningly. I've been working on professionally as a software developer for I think 38 years, and I've done all kinds of different software. I was one of the authors of a reasonably influential book called Continuous Delivery. These days, I make a living largely as a consultant, helping organizations to improve their software engineering practice. And that's probably going to be a theme for me in talking about some of this stuff today, because I think that's one of the things that glues together the stuff that I'm passionate about, and thinking about applying engineering thinking. I've done all different kinds of software. I've written embedded stuff, operating system level stuff, large distributed systems. I kind of finished up my career as a hands-on software person, writing mostly trading systems and exchanges and stuff like that. So any questions around architecture, high performance, coding techniques, all of those sort of things, I'm absolutely cool with. Also, I'm really interested in the practices and processes that allow us to do a better job. So how do we approach software development in a way that gives us a higher likelihood of success? And that's what I think that continuous delivery is about, and some of the other stuff that I hope that we're going to get to talk about today.
Wonderful. So just on that theme, we've already covered that you really were one of the pioneers of the continuous delivery and deployment movement. How did you start spreading the word about those principles? And as a follow-on from this, what do you think the next idea will be in changing the way we produce software? Where will it come from? And how will it be spread?
So I want to answer that in two different ways. So the second question in two different ways anyway. One from a selfish point of view and another from a more general industry point of view. But the first question first, in terms of how we started promoting the ideas of continuous delivery. When Jez and I wrote the continuous delivery book, we were both busy working on projects. I was in the middle of building a financial exchange. Jez was starting work, I think, when it was published on the Go team, the ThoughtWorks continuous integration and continuous delivery product. And so we were busy with our day jobs mostly. So we did bits and pieces of talking at conferences and that kind of thing. But it wasn't until the book was kind of a little bit of more of a success than we thought that we started going out and helping it along. And both of us were kind of talking at conferences and those sorts of things. I think that in general, in terms of the success of continuous delivery as an idea, which is certainly outstripped, I know, what Jez and I thought when we wrote the book, then I think that the success of the idea is much simpler than that. Continuous delivery works better than any other approach that we understand of how to create software. And we have data and evidence to back up that rather bold statement. When we were writing the book, Jez and I were both a little bit nervous of talking about it as a methodology or an engineering practice, because we were just kind of assembling these practical things that we had learned largely through screwing up lots of times on different projects until we found something that worked better. And so And so we were a bit reticent to talk about that. I've learned more since then, and now I'm a little bit more willing to make some of these bolder statements because I've got more evidence. I've got more stuff to back up those kinds of assertions. In terms of what's coming next, I think I think that there are some ideas that really move the game on, and I think that there are several of those ideas that I've seen through my career. I think that agile thinking, particularly some of the engineering principles from extreme programming around test-driven development and those sorts of things, which I think of as foundational for continuous delivery, were hugely influential on me. I think that agile was a liberating step in a really interesting way. In that if you think about it kind of from a philosophical point of view, then a waterfall approach to software development means that you have to understand everything at the start. An agile approach to software development doesn't, which means that it's unbounded. So an agile software development approach is a much broader spectrum. It's, if you're interested in physics and have read David Deutsch's book Beginning of Infinity, it's the beginning of infinity. It's one of those kinds of steps that liberates thinking and approach. So agile was an important step. I think one of the craftsmanship, software craftspersonship was a huge step forward too, but I think that's not enough. I think that if we start applying take one more step and start applying a little bit more engineering thinking, where we start measuring, using data, controlling the variables in our experiments in software, move us forward. And that's really the theme of my work these days. That's the kind of stuff that I'm working on, how you kind of apply that kind of engineering thinking and move stuff forward. So that's my kind of selfish take. More broadly in the industry, I don't think that, I think that we are an industry of change, but a lot of the change doesn't matter very much, because it's kind of a bit of a fashion. It's just what's current today. I'm currently writing another book, which is going to be published later this year, I hope. And one of the experiments that I'm doing as part of the book is I tried out writing some software using the latest web-based technology, using a modern system to write a simple CRUD application. And I tried doing that in the technologies that were around in 1996. And so far, I haven't finished with my experiment, but the 1996 technology is about a quarter of the code, which is interesting. There were certainly things that the new stuff was better at. There's certainly things that were, the kind of cross-browser stuff and all that. The new stuff brought some things, but the programming model was more complicated, which is an interesting observation. So I think that it's not frameworks and things like this. What I hope is that we start to take a slightly more disciplined approach, a slightly more rational approach to the way in which we start solving problems. And that's where I think that the real huge wins are for software development. One more just kind of sexy technology, because I am a nerd at heart. One of the technologies that kind of fascinates me is, on the horizon, it's been on the horizon for a while, but it is coming soon, is massive scale non-volatile RAM. If you think about the history of computing, the design of our systems is nearly all about the difference between the live stuff that's in memory and being processed at a time and the stuff that we store, somewhere else to slower storage. If we have massive scale non-volatile RAM, if we have terabytes of RAM, but we can turn the computer off and it just remembers everything, that's going to change the game. It's going to change the nature of our designs in some really interesting ways.
Yeah, that's a really cool point. I hadn't heard of that. Wonderful. Nice. So still sort of on the sort of more philosophical, strategic side, I have a question. So firstly, thanks to Avi for the first question. And the second question is from Jagandeep. And he wants to know how you include strategic domain-driven design into your work, if at all.
So I think domain-driven I had a funny reaction when I first saw the domain-driven book by Eric Evans when it was released, and that was, I was an old school OO guy, and I was reading, I was saying, yeah, but isn't this obvious? And then I read the book more carefully, and there was some fantastic things in that book. It's the book I most wish that I'd written. the domain-driven design book. It's a fantastic book, and Eric Evans is a brilliant person. I just love. He sparks with ideas, which is great. So I'm a big believer in domain-driven design, and for a variety of reasons. One of the key ones is that domain-driven design is a fantastic tool to really focus on the separation between essential and accidental complexity in the systems that we build. If you care about separation of concerns in your design, domain-driven design is a tool that you can use to steer you to separate the concerns in two different dimensions, both within the problem domain in terms of where are your bounded contexts and all that kind of stuff, but also technically to separate the essential from the accidental complexity. I've mentioned it already. I led a team to build one of the world's highest performance financial exchanges. We built the most beautiful infrastructure that allowed us to build our system. The architecture of our system meant that our day-to-day work was largely focused on these little pure bubbles of domain logic, and all of the accidental complexity of clustering, disaster recovery, persistence, even high performance, all of those things were outside of those little bubbles. Performance, you had to write those things so that they were reasonably performant, but apart from that, it was all outside. And that was the most beautiful system that I've ever worked on in terms of a big system, but a habitable code base. The way in which it plays out in my approach to development and design is on multiple fronts. So first, as I think I've already demonstrated, I'm a fan. I'm a believer. So I walk into a problem by trying to model the problem domain. That's where I start from. I try and figure out those things, and I'm the thing that wasn't in Eric's book, but that was added later, and he's kind of part of that community now, is the idea of event storming as an analysis technique to explore a problem domain and understand what's going on. So definitely work there. The other thing that I think is probably less obvious, but is really profoundly important to me, is I take a very broad view of what test-driven development means. So my preferred approach to test-driven development is that I'm going to create an executable specification for each behavior of the system that each feature of the system that I'm trying to develop. And that is in the form of, in the language of the problem domain. I'm going to write something in the language of the problem domain that expresses from the perspective of an external user of the system what the user of the system wants from the system. And I have a YouTube channel, and there's a little video that I did on my YouTube channel of buying a book from Amazon. So what's a test case that we could imagine to buy a book from Amazon? Well, we'd go to the store, we'd search for a book with a particular name. We'd search for a book called Continuous Delivery. We'd put the book in our shopping cart. We'd go to the checkout. We'd pay for the book, and at the end, we own the book. That's my test case, and that's how I'd write it down in that language. If I could capture my test case in language that sounded like that as an executable thing, I could just as well apply that test case to a robot shopping in a real bookstore, for example. I could imagine the robot driving down the street, going to the store, walking around the store, reading books off the shelf and all that kind of stuff. So this level of abstraction decouples us almost entirely from the implementation of our system. So that's the other way in which I think domain-driven design deeply impacts on my approach to system development and design. So I will create these executable specifications as the first thing that I do for a new feature, and then I'm going to, underneath those, I'm going to do fine-grained, more technical TDD until those specifications are met, and then I'm done. So I think that domain-driven design is part of the kind of organizing strategy to achieve good, high-quality software engineering. It gives you all of these lovely properties of separation of concerns and separation of accidental and essential complexity, and you get this kind of way of driving the design from the consumers of the software, whatever that means. Like sometimes the problem domain is technical. A consumer could be another piece of software somewhere, but it's always behavioral and expressed from the outside.
And have you come across any strategies that help you affect that change of mindset in your team? Because it is a bit of a shift for a lot of people, myself included. I know all the theory, but then in practice, you do become a little bit fixated, I suppose, on the technical aspects of things. I mean, we're nerdy people, most of us at heart. It's interesting, right?
Yeah.
So what have been some strategies that you've come across to maybe really entrench that behavior?
So that's a great question and a really difficult one to answer. But I think the first strategy, and the one that's kind of implicit in what I just said, is that you write the test first. So stop messing around writing the code and then trying to test it afterwards. That gets in the way. All of us, however disciplined and diligent we are, if we do it that way round, then the code that we just written is fresh in our heads, and we end up testing the implementation rather than the behavior.
Yeah.
So you write the test first. You write the test before you've got any code, and if you do that, it kind of, unless you're really dumb, then you're going to try and make your life easy. Because why would you want to make your life hard? And it's much easier to write, if you select for ease of writing these tests when you're writing them before you've written the code, what that tends to do is it tends to naturally drive you more towards this behavioral viewpoint. I think the other side effect that's really interesting when you do that is that so if you think about what the properties of high quality code are, that I would list 5. So it's modular, highly cohesive, good separation of concerns, it exhibits information hiding, and is loosely coupled. I think nobody would argue with those 5 things. So what does it take to achieve testable code? If you write in the test first, well, it needs to be modular so that you can kind of see into the code. It needs to be cohesive so that if you're testing something, you're testing the behavior that's there in front of you and all of it. It needs to be loosely coupled so that you're not too tightly coupled to the code, so that the code can move independently of the test and vice versa. It needs to be exhibit information hiding. You don't want all of the internal details to be represented in your test. You want the test and the code to be separated somewhat so that, again, they can move more independently of one another. And I've forgotten which one I've left out. Oh, abstract. So you need the loose coupled, abstract, cohesive, modular. What did I miss? Separation of concerns. Separation of concerns. You want a great separation of concerns so you can focus your test. You don't want to be, if you're testing some business logic, you don't want to be worrying about the database or whatever else is going on. That's all noise. So I want to focus in. And again, that kind of drives us towards this nicer domain kind of focus, I think, for those pieces of the code. And so I think this is a trick. So this is a good way in. So I have a few kind of mental tricks that I coach people to apply to try and focus on these kinds of things. And again, based on writing the test. So whenever you write a test, imagine that you throw away your implementation and replace it with something entirely different. Does the test still make sense? If it doesn't, then it's not good enough. If there's a problem of your test being too tightly coupled to the code, that's not a problem with your test. That's a problem with the design of your code. So change the design of your code. The other thing, particularly for these higher level executable specifications that I was talking about before in the language of the problem domain, when you're creating those, imagine the least technical person that you can think of. Could they read the test and understand what it means? And the least technical person who you can imagine who understands the problem domain, could they understand what you're talking about? If they can't, you haven't got the language right. You haven't got the abstraction right.
Right.
So I think that's key, and a lot of this is to do with one of the kind of primary evils, as I see it, in software development, which is coupling. The biggest stumbling block to scaling up, to good designs, to the ability to make changes in a code base is coupling, really. If we had loose, narrowly focused little bits of code that I can change independently of other parts of the system, that's a nice kind of code base to work on. If I touch the piece of code here and it's likely to break your piece of code over there, that's an unpleasant kind of code base to work on.
It's nerve-wracking.
Yeah. So coupling is the enemy. Coupling is the thing that we need to be at the forefront of our mind all of the time and working to just manage. We want to think about that really carefully.
Well, there's some really good points there. I'm going to revisit this video later. I can be a little bit guilty when it comes to writing the code and then the tests. So I think this is some really good advice. I'm definitely going to revisit that later and really try to craft that or push myself to be more disciplined in that respect. Really appreciate it.
So one more thing. I'm just going to push my YouTube channel. I've got some videos on all of these things which will help you with that. There's a really nice one on coupling, which is about how do you build big software with small teams. And there's a whole series of things about test-driven development, acceptance testing, and so on. So go along to YouTube, search for Continuous Delivery. You'll find my channel.
Yeah, I watched a few videos in preparation for this event, and yeah, it's really great content, and it still just amazes me that there is such high quality free content available on the internet. I mean, it's a great time to be alive.
Yeah.
Pandemic aside, it's still a great time to be alive. So this is quite a long question, but I'm going to read it in full because I think it's a situation that maybe a lot of people can relate to. So I'm quoting directly the asker of this question, who is Lars. So Lars says, I'm surprised by how some of my colleagues reacted negatively when we introduced quality gates into our build pipeline. This was done from the very beginning of the project, so only new code was affected. For example, with Sonar Cloud, CPD, Spot Bugs, JCoco at 80%. These tools help us write better and more consistent code, and some of us were quite happy, but others saw it as completely obstructing their work. And after they complained to management, we were actually forced to disable quality gates. Why do we as developers respond so differently to quality gates being forced upon us? Is there any advice you have on how to handle this?
I can absolutely give you my take on why that's the case and what it means when it's the case. I can probably talk a little bit about ways to get around it, but this is one of those things where the really difficult part in software development is us. It's people, and getting people to think differently and to change the way in which they approach their work is incredibly difficult for even small groups of people, let alone when you start talking about large teams and so on. So there are always problems around these kinds of issues. I think that one of the things that we have done that I think is desperately problematic for our industry is that we've kind of abdicated the responsibility for the software that we create. We've tried to hand that over. If we don't know how to build something, it's because people haven't told us the right requirements. If we don't understand the problem domain, it's people didn't write that in the requirements properly. If we get the UI wrong, it's because somebody didn't do the UI design properly. We're software developers, and our job is solving problems, not writing code. Code is the tool that we use to solve problems. And so I think, sorry, I'm very opinionated on this. So I apologize if I'm treading on it, trampling anybody's sacred cows, in this. But I think that we've got to suck it up. We've got to take more responsibility. The best teams that I've worked on, the software development team, felt responsible. They felt that the system in production was their product.
Yeah.
Was whatever that is. That's the job. That's your job. Your job isn't to write some code and get some brownie points because you wrote more lines of code than the next person or anything like that. And I think that one of the reasons why people And we've fed and perpetuated a whole culture, organizational cultures and development culture around this kind of thinking. It's really, really common I hear it nearly every time I go into a new organization is, oh, I'd like to do all the stuff that you talk about, but my manager won't let me. Or we'd really like to do tests, but we don't have time. We've got a deadline to hit. I find it really, really hard to understand that kind of thinking, because the stuff that I talk about is measurably the most efficient way that we know how to write software. It's measurably the best way that we know how to write high quality software. So if we were being rational and we looked at the data, everybody would do the stuff that I'm talking about, because that's what works. And this is the stuff that happens in all organizations, the really successful organizations. This is the kind of approach that they work. Now, it's stuff that we've learned relatively recently in the history of software development, but it's important stuff. The difficulty is if we abdicate the responsibility for parts of this process to managers in the organization that don't really understand what it is that we do, they're going to make bad mistakes, and they have. If people start pushing people and asking them to speed up by reducing quality, that's just stupid. You might get away with that for a week. You're not going to get away with it for a month, but after a month, your code will be costing you more than it did, than you saved, because you'll be fixing bugs and reacting, being slower on development because the quality of the code is crap, and so on. So working with high quality, taking responsibility for the quality of our work is important. I think of it as a professional duty of care. If you employ me to write software, I am not going to ask you for permission to do a good job. I'm going to assume that you employed me and you're going to want a good job. If you hire me and you want me to do a bad job, I'm going to go and find somewhere else to work, if I'm honest. But I think it's important to kind of own that responsibility. Now, this isn't the argument that's going to convince everybody. If your colleagues are saying you're slowing me down by making me do quality things, then that's a big problem. So how do you practically start to address that? I don't know anybody that's really worked the way that I describe that doesn't prefer it to the way that most people, developers. Now, that doesn't mean that there aren't people that don't argue against it, but they don't argue against it if they've tried it. I don't know anybody that does, because it focuses you on the stuff that we all love, that we're all passionate about software development. That lovely moment of discovery when you get to solve a problem, that the insight that you get, if I do that, this code's going to get simpler and clearer. I can make change safely. I can move really quickly because I've got the backup of good tests and feedback on the quality of and effectiveness of my work all of the time as I'm working, and that's a very, very addictive drug. So part of it is trying to find ways organizationally where you can start drip feeding that to people. And the easiest way to start doing that is to try and solve a problem that they've got, and try and figure out how you can help them solve a problem that they've got. But you demonstrate, through what I think of as better engineering, how that solves the problem that they've got. And that starts to get people, even the people that are reticent, it starts to get people more on your side. There's another trick that I have tried and I read about I think I read about it in Linda Rising's book about fearless change, about change patterns in organizations. But the idea is that if you are trying to effect a change in the way of working in an organization, you're definitely going to get some people that push against you. And one of the ways in which you can do that is, if there are people that are really, really angry and against you, Go to them and engage with them and say, you clearly disagree with what you're doing. Will you take that position, please? I'm not asking you to change, but argue against me and have the debate, make it official. And often you can kind of win them over. It feels like a bit of a trick, but having them being recognized, people like being recognized. You're not rubbishing their decisions. You're just trying to normalize the ability to have a conversation that tests an idea. And that way you can explore the ideas. They can challenge any, things that you come up with, and then you kind of react with evidence, data. So okay, well, maybe you've got a good point. How could we try that out? And all of these sorts of things. And if you do that, you're going to end up where I am, not where they are. I'm not saying I'm always right. I'm just saying that the stuff that we talked about so far is, that works, and that's the better way of doing it because we've got the evidence.
So I have another question from Avi, which just came up while you were speaking. I think you partially addressed it, but let's just be really explicit on it. So they say, thinking about quality gates, you'd want to be able to show management that gates help, but how can you do that without it taking months? So how do we make good decisions in a timely manner?
So I think that's a fundamental of continuous delivery. I would argue that continuous delivery, if you wanted sound bites to capture what continuous delivery is about, it's about working so your software is always in a releasable state and achieving that and optimizing for fast feedback. And the target that I set my clients to aim for is that you want to know that your software is in a releasable state at least multiple times per day. So at least twice per day. Ideally, my recommendation is that you want to be able to get it in under an hour. Now, that may, if you're working on a big legacy system, if you're working on something, technically complex, that may sound ridiculous and impossible, but it's not. You can do this if you believe that it's important enough to do it. Just as one example of, being able to do that. Volvo trucks apply to continuous delivery. Inside of modern Volvo truck, there are 18 different computing devices talking to one another in a sophisticated network. There is something in the region of 80 million lines of code. It used to take them 6 months to get a single line change in code into a truck on a test track. Oof. It now takes them 20 minutes.
Nice.
Imagine the difference in working on that feedback cycle. So just optimizing to reduce the feedback cycle. The quality gates are important, but if a quality gate slows you down, that's a huge problem. There is data from the State of DevOps report that says that things like change approval boards or manager sign off and stuff like that are negatively correlated with quality. If you have a change approval board, you're making worse software, not better. That's what the data says. So working with really fast feedback and engineering to get that feedback so efficiently that you can get clarity on where you are as you're developing things, that's the real game. Now, to get there, depending on where you're starting from and how complex your software is, it might take you years. But the advantages are so huge if you can get there that it's worth that effort. And that doesn't mean you're doing nothing for years. Every little step along the way improves things. So you're going to get. So I usually say that's kind of an activation energy. You're going to start off 3 or 4 months being slower in a big organization with a large legacy code base. You're going to start off 3 or 4 months being slower as you learn the new techniques. After that, you'll be faster than you ever were before, and you'll continue to accelerate from then on. You'll be more efficient from then on. So I think that's. So yeah, absolutely. My ambition is to work with very, very high quality. I think I've worked on systems that are higher quality than most people have experienced. I think I'm not saying that to boast. I'm just saying that the engineering practices that I'm discussing allow us to do that. When we released our Exchange, it was in production for 13 months and 5 days before the first defect was noticed by a user of the system. That's how high quality that system was. And we could get an answer to any change to our entire enterprise system in under 57 minutes. So part of this is just believing that it's possible, because it sounds so extreme. It sounds so ridiculous.
Yeah.
But it is, and you can do it on massive scale in complicated software, but you've got to believe and you've got to start doing the engineering to start improving things. And that's about getting more control, exerting more control, applying this kind of engineering thinking that I'm talking about more and more and more and more until you're at the extreme where I'm talking about.
Yeah, it's not an easy job, but it's an important job, and I guess that's how you've made a career out of it, right?
Yeah. It's one of the things that I love about this job. I suppose I'm weird, but I like that it's hard. I like the hard problems. I enjoy the reason. I had a fantastic job. I was working at ThoughtWorks, the consultancy, and I was the senior tech in the UK in ThoughtWorks at the time. I was kind of traveling around advising them on the projects, and I had a really, really great job. And a friend of mine came along and says, "We've got a problem. We've got no clue how to solve. It's really, really technically hard. We've got no idea how to do it." And I went away and did that. That was building this financial exchange, because it was just such a lure because nobody knew how to do it. And so I love those kinds of problems. I love the really hard problems. But software development, even what looks like simple software development, it's an illusion. Software is very, very slippery stuff. It's very easy to get into really quite seriously deep water quite quickly in software. As soon as you do anything that's concurrent, you're kind of up there close to how complex quantum physics is. It's really, really difficult stuff, and I think that trying to paint over it and make pretend that it's simple is wrong. So facing up to the complexity, I think, is part of the game. So if it's this complex, how do I protect myself from the complexity?
Yeah, not by making it more complex.
Not by making it more complex, doing everything that I can to keep everything that I'm working on as simple as I can.
Yeah. So I'm just going to do a little bit of a shift, because certainly from my background, it's not something I have a lot of experience from, but I'm quite interested by this question. So this is in relation to embedded systems. It comes from Lars again. So do you have any experience or advice on bringing senior principles to embedded platforms?
Yeah.
Specifically, some kind of automated test bench is probably needed, according to Lars. But do you have any recommendations for things to consider when setting it up?
Yeah, it's a very common question, and of course, depending on, I'm just going to slightly broaden my answer a little bit. The technology of your system is going to have an impact on how easy it is or how complicated it is to apply some of these ideas, but it is applicable. So it's a long time since I wrote any embedded code myself. So now I am talking largely as somebody that was leading teams or advising teams that were doing this. But yes, I've got a fair bit of experience. I worked in a trading company where we were doing the things that program ASICs, the FPGAs, field programmable gate arrays. We were doing FPGA programming, and we did that using continuous integration, continuous delivery. Now, when you're programming an FPGA, there's a cycle. It takes you a while to burn the silicon. That's physics. There's a process that you can't speed up. And so what you do is that you do way more testing in simulation. And that's the key nearly always when you start talking about software that's really close to the hardware. One of my clients that I've been working with for a few years now builds very, very sophisticated scientific instruments. And they build the whole stack from the hardware, firmware that operates on that hardware, device drivers that operate on that, the operating systems that kind of drive that hardware and firmware, and all up the stack until you're into kind of cloud-based solutions distributing information. And the hardware teams are some of the more hardcore continuous delivery teams, because it gives them such an advantage to be able to test their stuff. And again, you test it in simulation. If you think, if you start thinking about engineering, I'm a space nerd, so one of the things that comes to my mind is either SpaceX or NASA. And if you think about NASA didn't build the Curiosity rover by by sending it to Mars and seeing if a problem occurred and then getting a bug report. They had to simulate all of that stuff. So you test more in simulation, and that's how you solve the problem for embedded systems on the whole. And the actual the assumption there is that you evaluate your system, as close to its edges as you can to simulate all of the behaviors in the system, and that the actual act of burning the silicon, or whatever your version of that is, depending on your stuff, that's pretty reliable. You're unlikely to get too many mistakes there. It's the design of the system where the hard part is. So that's the stuff where you focus the majority of your testing effort. And then you can do other things. So I have one client that actually has a little farm of robots that test physical things. So they put cards in machines and stuff like that to evaluate things. So it depends how far you want to go. I think that the engineering thinking is, rather than thinking what are the technical limits of, how do I limit myself because it's hard to test this stuff, and rather starting from, we're definitely going to test this stuff, how far do we have to go to be able to test it, and how do we make our lives as easy as we can? And one of the impacts of that is it starts you architecting the software somewhat differently. So whatever the nature of your software, when you start talking about automated testing, the difficult bits are the bits that touch the real world. So UIs are more difficult than the business logic. Databases are more difficult than the business logic. Even something as simple as writing to a file system is more complicated than the logic. If you can test things in memory in a computer, that's the most efficient way of testing things. And so you tend to push those things to the edges of the system, evaluate all of the other behaviors, and then you kind of test just those little thin bits of software that actually interact with the real world.
Yeah. So the principle is very similar. I mean, a test environment is just another form of a simulation, you could say. Yeah. So the principles are really, really similar. It's just the way it looks, perhaps in practice, is just a bit different.
It's one of the superpowers that we as software people have, is that we have at our disposal almost the perfect experimental platform.
Yeah.
Because we've got these computers, and these days we've got the cloud. We can spin up whatever we can create these little imaginary universes in which to evaluate our software, and we should just really take advantage of that.
Yeah, absolutely. So now we've sort of talked more sort of strategy and philosophy. I want to get into some more sort of pointed technical questions. We don't have too much time, so let's see how many we can get through. So Cassia asks, what Git branch strategy do you consider the most efficient?
The most efficient strategy, and again, there's evidence for this, I'll point you in the direction of the Accelerate book and the State of DevOps report, is to work on master all of the time. So you work on master locally, and then when you've done, you make many, you divide your work up, so you do many small changes, you commit multiple times per day, and you sync that with origin master. That's the most efficient way of working measurably. And one way to think about this is the definition of continuous integration. So both of the words matter in continuous integration, the continuous word and the integration word.
Yeah.
Again, check out my YouTube channel. Describes this in a bit more detail, complete with quotes of where I got some of this from. So continuous integration is about evaluating our changes as close to continuously that we get. The original idea that they had on the C2 team when Kent Beck and his mates came up with the idea was that if you could imagine working, and as soon as you had anything that was kind of close, it instantly appeared on my screen and I knew that it all worked and it worked with my software, how wonderful would that be? And we try to get as close to that as we can. Now, the cost of continuous integration means that we have to find a way of working that allows us to commit changes. And certainly if you practice my flavor, continuous delivery, and those changes may end up in production for features that aren't finished yet. That's the cost, that's the downside. But now let's think about branching. Any form of branching, whatever nature of branching, is about hiding change. So immediately it's in competition or at a different end of a spectrum to continuous integration. Continuous integration is about exposing change, and branching, any form of branching, is about hiding change. part of the definition of continuous integration. I'm never quite sure. It's possible that I added this to the definition of continuous integration because I was certainly saying this stuff and popularizing it at the time, and I can't remember I can't remember whether actually when Martin Fowler wrote it down, whether he was listening to me or not at that point. But part of the definition of continuous integration is that you should be integrating to the main line, the shared truth of your system, at least once per day. So if you have any branching strategy, GitHub, Gitflow, or anything like those, whatever, GitHub Flow, whatever branching strategy, if any of those branches hold your software away from the releasable main line of your software for more than a day, it doesn't class as continuous integration, which surprises people. But I think it's an important idea because continuous integration brings a whole, with the cost of working in these small little changes, so you have to think differently about change. Again, check out my YouTube channel. There's a good video on this. Working and holding your feature until it's finished on a branch, if that lasts for more than a day, doesn't count as continuous integration. And the data says you are working less efficiently and you create lower, statistically, you work less efficiently and you're creating lower quality software if you work that way. Now, that doesn't mean that you're always going to be working slower or creating worse software. It just means you have a higher likelihood statistically that that's what's going to happen if you work that way. So continuous integration is the best way that we know measurably to create high quality software efficiently. But it requires a mindset change.
Right. And I think this leads into our next question, which is more sort of an agile related question than a pure CD question, but of course they're related. So this comes from Garth Gilmore, a fellow speaker from GOTO, and he asks if it's possible for iteration sizes to become too small. For example, does 2 weeks leave enough room for design decisions and the everyday disruptions, such as speaking at conferences, that affect teams?
I'm not sure. So I see iterations differently. And I think that working in a continuous delivery, part of my definition of continuous delivery, I've mentioned it already, is working so that your software is always in a releasable state. That means after every commit. So if I'm working the way that I've described, if the teams that I work on, we'd all be committing maybe once every 10 or 15 minutes. We make a tiny change and we commit it. It's going to go through our continuous integration system. It's going to be evaluated. It's going to go through our continuous delivery system. It's going to be evaluated to a releasable outcome. And it could be released into production. So now I've got to start to adopt strategies that allow me to work that way. But that means it doesn't really matter how long the features take because I've separated out my ability to make change with my ability to release. So that doesn't mean so my preferred way of organizing this from a planning point of view or a work organization point of view is Kanban. So you kind of maintain a backlog of stuff and you just work on you just pick the next priority to work on. When you come free, you go and look what's the next highest priority and you pick that and you start working on that. That's essentially what Kanban is. There's a bit more to Kanban than that, but essentially that's the planning part of it. That's the most efficient way of making change. The downside for Kanban is a human one. I worked on some of the teams in kind of the early part of this century that were experimenting with lean techniques, and one of the things that I observed, that I believe that we saw on those teams, was that after a while of working Kanban, it just kind of feels like you're on a treadmill. You're just churning feature after feature. There are no highs and lows. And one of the things that I value from a more iterative approach, classic agile iteration or Scrum sprints, that kind of thing, is that it kind of gives you a more human cycle. You kind of get together at the start of the iteration and have cake and discuss what you're going to work on and all that kind of stuff. You can get together at the end of the cycle and celebrate that you know what you did and so on. It doesn't have to align with releases. It doesn't have to align with features. But it just gives you a bit more of a human cycle. So my preferred approach is that I use the iterative cycle to give a little bit of the light and shade for kind of a human, a nice working environment, so that we can just kind of get together, celebrate our successes together, do a retrospective and figure out how we can do better in future, those kinds of things. But the actual work is we do tiny change, tiny change, tiny change. Again, this is one of those slippery things. The challenge here is that it changes the way that you think about design, I think, for the better. So my belief is that you never build a complex system by sitting down and thinking really hard and planning out a complex system. You build a complex system by starting off with a simple system that works, and then you grow it bit by bit by bit. So I think of software design and architecture and development as much more of an evolutionary process, and our job is to kind of guide and steer that evolution. We can figure out which branches are going in the wrong direction and which are going in the right direction, and so we can work much more iteratively. It gets back to the kind of stuff we talked at the beginning, where I can't remember, we did talk about it at the beginning, but the small teams more independently of one another and having more, making choices and directing their own destiny. You want to scale up, you want to kind of distribute decision making. And one of the ways in which you do that is by making these small changes and not trying to coordinate everything together. So I think that it has a positive impact on design, but I think probably not in the way that the person asking the question was thinking when they asked the question, maybe.
We don't have a lot of time left. Actually, let's just say a couple of minutes before we have to wrap up. I see about 3 questions around a similar topic, so I'll just get you to a free form and answer. This is actually around code reviews and pull requests. So from what I'm gathering from what you're saying, if you automate all the things and your changes are really small, it might not be necessary, or what's your opinion around that?
So I value code reviews, but I think that they're not as good as pair programming, which is a continuous code review, but a whole bunch of other things too. Again, check out my YouTube channel, good video on pair programming. So my preference is to work doing pair programming. That gives you this kind of continuous review. That works in regulated industries, counts as a review. It's not a problem. And I think that you get much more out of it than just the code review. So that's the thing. You can add code reviews as part of your deployment pipeline, as part of the cycle. It adds complexity and it has a tendency to slow things down. It's not ideal. So my preference is to do pair programming for that.
Well, have you come across any good software for that, given that a lot of us work from home?
Yeah, I've done quite a lot of remote pairing. I confess I haven't done any since the pandemic, because most of the software I develop these days is on my own. But I've done a lot of remote pairing. I was once part of it. I'm based near London, and I used to have an office in London, and my primary work was with a team in Chicago. So we used to do remote pairing when our time zones overlapped. So I don't think you need anything very sophisticated, to be honest. You need to be able to share a screen, and you need to be able to talk to each other. The next step beyond that is it's kind of nice to be able to see each other. So something like Zoom or Teams or one of those kind of tools is kind of handy to be able to share a screen and be able to see each other. I worked for a trading company. They had quite a lot of money, and they invested in big screens that they put at the end of the desk. So it was kind of a bit like the Chicago office was an extension of the London office. I could kind of look down and I could see my colleagues, in the screen, as though they were sitting next to me almost. So it was almost like VR. I think VR is going to be a big deal for this kind of thing in the future. But right now, I don't think you need very much. I think you just need the ability to share a screen and swap who's actually. You need if you're doing the fine-grained commits that I'm talking about, you can kind of you write a test, run it, see it fail, write some code, run it, see it pass. refactor it, commit it, and then swap over then I can pull that change and I will write the test and I'll I'll take over and we can swap backwards and forwards. It's relatively straightforward. There are some, if you Google for this stuff, there's some stuff on this online about remote pairing, but I don't think it needs any great tech to be able to achieve it, more than the normal sorts of tools that we use these days.
Wonderful. Well, I think that's a nice note to end on collaboration and the fact that we can still do it in these times. Before we wrap up for today, I just want to let you know that Dave is actually a really prolific contributor to the tech space, especially in this area. So it's not just his book on LeanPub that's coming up. He has a mailing list for regular updates. He also has his YouTube channel. As I said, I've watched it in preparation for this. It's really great. They're more bite-sized than maybe a conference talk, 10 to 20 minutes. So perfect to watch while you're cooking tea or something. Also, of course, you can find Dave Farley on Twitter. It's just at Dave Farley 77. All of this information will be placed in the description. So I would like to thank Dave so much. I've certainly learned a lot today, and I hope that our viewers have as well. And Dave, I just want to check in with you before we wrap up. Is there anything else that you would like to remind our audience about in terms of what you're doing at the moment?
The one bit of sales that I will do, 2 bits of sales. I have some nice online training courses. If you go to courses.cd.training, you'll find my stuff. And I'm writing another book. So I just announced the publication of my Continuous Delivery Pipelines book today, which is a practical manual. I'm writing another book, which is about software engineering and talks about the philosophy and approach that we've discussed a little bit today. That's going to be coming later in the year, so keep an eye out for that too.
Wonderful. So thanks so much again to Dave and our audience. I really hope you found it informative. I definitely did. We also have more AMAs coming up with some more excellent names. So please stay close to us, and we hope that you enjoy our content moving forward.